Yeah, that looks cool. Yeah, that works. Okay, perfect. Let's start because we're a few minutes late. So I'll be talking about Node.js application security or insecurity. So before I do that, who am I? Well, my name is Ilja van Sprundel, which is what it said on the first slide. I work for a company called OWASP, my colleagues in right there. I'm the director of penetration testing for OWASP. I basically, I do pen tests or lead pen tests. Mostly my job revolves around reading code, testing code, breaking code, hopefully breaking code. And so, yeah, I break stuff in front of profit, basically. Right, so what's my agenda? What am I going to talk about today? So I'll say a few words about what I'll be talking about, and then sort of give you my target audience. Then I'll sort of dive into, well, what exactly is Node.js and why am I looking at Node.js? And then I sort of start diving into actual details, right? I spend a little bit of time looking at entry points. Node.js entry points are really easy, so that's like one slide. And then I sort of dive into, these are all the things that can go wrong with a Node.js application, or more precisely, these are all the things that will go wrong when you look at a Node.js application. And then I kind of a conclusion, and after that I can leave it open for questions. Right, so this talk isn't about Node.js itself. It's not about bugs in Node.js. It is in bugs in Node.js applications. It's kind of a subtle difference, but it's a big difference, right? One is old native code, one's old JavaScript. Very different types of bugs. There's a little bit of crossover. Near the end, I'll dive into a little bit of Node.js details, and you'll see a little bit of C++ code. But that's really just to give a bit of context around Node.js application stuff. Right. So my audience is kind of just sort of threefold, right? If you're a Node.js developer, you are definitely my target audience. I would love for you to come here and hear this, and hopefully, learn what not to do, or learn what bugs are like and how to fix them. Obviously, my secondary target audience is security people, right? I am one of you, and so I'm here to sort of spread some of the knowledge, or hopefully some of the knowledge that I've gained about Node.js. So it's basically sort of, if you're a security reviewer, what you could learn would be what to look for and where to look for it if you're ever involved in a Node.js security review. And then obviously the third target audience is, if you're just a curious web guy, or your Node.js is really your thing, or neither of those are your thing, but you like security, then this could be interesting, right? Right, so what exactly is Node.js? Well, Node.js is basically a server-side environment for most web applications. You also write web services and a bunch of other things. And the whole thing is written, the whole thing runs on JavaScript. It's a JavaScript environment. It's based on Google's V8 engine, so it's the same JavaScript engine that runs in Chrome, basically. They bolted their own APIs and framework on top of it. Everything is single-threaded. So they had a bunch of SQL APIs. This is a small list, but the list is really actually really long. And the Node.js website has a full list of all the areas of things that they add, because obviously files, crypto, and execution processes, but also there's networking and a whole bunch of other things. I listed these four because these are the things that I'll dive into during this presentation. So that's just the C++ APIs. And then on top of that, they have a fairly big JavaScript runtime that they actually expose to the developer. And that runtime is basically just the bridge between C++ stuff and the application. Right, so why am I looking at Node.js? Well, Node.js, it's in pretty common use nowadays. A lot of people write Node.js. And so the reason I sort of got here is because I've been mildly involved in a few little Node.js applications, and then one of my colleagues said, hey, we need someone to write a full-on loaded Node.js penetration methodology. And writing those things takes effort, so I went ahead and started playing with this stuff and sort of making a list of if I'm going to pen test these things, I would do this, and I would look for this, and I would do this, and then that can go wrong, and this can go wrong, and that can go wrong, and so forth and so on. And so after a while, I had this entire list, and then that engagement never really happened. But I had this stuff laying around, and then one of the organizers said, hey, Ilja, why don't you come speak at my conference? And they're like, well, okay, conference is what? It's called AppSec, it's OWASP, there's a lot of web app. I'm like, oh, great, I have this thing lying around that I haven't had any use for since. I could come present it here. And then, so Stefan seemed to like that. And that's kind of how this came about. And so basically, hopefully, people will learn a thing or two from it. One of the things I try to do is I try to have some real-world samples. And usually when I do these things, I go to SourceForge and I go download a bunch of sample applications and play with them. And I go to SourceForge and I couldn't find a single Node.js application in SourceForge. Not a one. The list of programming languages doesn't even include Node.js. So I'm like, why is this? What am I missing? And somebody goes, Ilya, you idiot. It's not a SourceForge. GitHub. GitHub's where you gotta go. And of course, GitHub wasn't my first point to go. So I think maybe it's a sign of getting old. I'm stuck in the SourceForge world, and apparently we moved on to a GitHub world. Right, so that's sort of the intro. So let's dive into some more details now. What does an actual Node.js application look like? Well, the cool thing about Node.js is that it's all built to be extremely easy to use, right? Pretty much any Node.js standard application looks like this, right? Where basically you say, okay, create me an HTTP server that listens on this port and binds to this address, and it just happens, right? And then you say, okay, you get a request, you get a response, I say this, I parse the URL, I give you data, I'm done, right? That's how an app looks like. It's that easy, right? That's all you have to, that's your report, that's your data, right? That's everything. It's that easy to audit stuff, right? You go look for this thing and you basically find your entry point. It really is that easy. Obviously, there's a number of frameworks built on top. So, and most people do tend, because this is sort of bare bones Node.js. The frameworks give you a set of more useful or more elaborate APIs, and so people do tend to use the frameworks. One of the most common ones is called Express, which gives you a super set of APIs, and it gives you these request routing methods and things like that. So it makes things easier. And then there's this sort of application development framework from the eBay guys called Kraken, which gives you, on top of that, a set of other APIs, including a bunch of security APIs and then those kind of things. There's a long list of frameworks. These are the two that I've looked at and that I know a little bit about. Right, so with that, let's dive into some Node.js security bugs. I sort of made these three categories: modern web application bugs, classic web application bugs, and sort of miscellaneous security bugs. And when I mean modern, and we'll sort of dive into it, this is sort of the standard web app stuff. Cross-site scripting, cross-site request forgery, response splitting. And this is basically stuff like, you're supposed to know what this is, but I'll sort of be like, okay, this is what it looks like in Node, and then if you're a developer, here's what we should fix. Bear with me a little bit. I know this gets a little bit boring, but there's a lot juicier stuff, like once we get past this modern web app stuff. Right, so cross-site scripting. I would imagine, I would hope everybody in this room knows what cross-site scripting is. Is there anybody who doesn't know what cross-site scripting is? Perfect. Right, so Node.js, given that it's this wonderful JavaScript environment to write web apps, web servers in, obviously there will be tons of web apps written in Node.js. And so if you're a reviewer and you have to audit Node.js applications, you will find cross-site scripting bugs, I guarantee it. Reflect, store, but you'll see them come by. Node.js has no magic API, there's no way to easily get rid of them, so they occur in Node.js as well. And so basically, if you go back to the simple sort of, create server, and then so this port and support, and you do this URL parsing, and sort of be, okay, well, I send data back to you when I echo name, right, this is sort of these reflective cross-scripting bugs. This is pretty standard stuff, right? That's exactly what a cross-scripting bug looks like. More specifically, that's what it looks like in Node.js. No surprises there. So yeah, if you're in Node.js applications, you will run into this stuff. And now, if you're writing Node.js applications, you should be aware of these, obviously, and you should escape the input that you echo back out, either be it directly from the user or when you get it from a database, right? There's a standard function to do this stuff for HTML. It's kind of like this, right? Where you sort of encode, you say, oh, less than, you make an ampersand LT semicolon, and there's a few of the others. That's sort of the standard way to do it, right? And that's for HTML. There's other ways for JavaScript, URL, XML, JSON, and so forth. And I'm putting this in here in case, you know, some Node.js developer stumbles across this thing here for now and he goes, oh, what's this cross-site scripting thing and how do I fix it? That's sort of the easy way to sort of get that stuff fixed. Now, you know, obviously, and we all know this, if you go and write your own escaping code and you have to call it every time, this is tedious stuff and it's error prone, and you know, we know you're not going to get them all. There's going to be like this one that you missed somewhere. And so Node actually, Node has this large community of like that publishes all these modules, and it has this easy tool called npm where you basically be like, oh, you fetch me this one and fetch me that module, and it all works relatively well. And so there's one of these modules for Node called Node Validator. There's a few others, but Node Validator is the one I looked at. And Node Validator is basically sort of the, you just include it, and then you say, okay, here's my string, escape it, you get escape string back. And you don't have to worry about anything else. If there's a corner case that's missed, it's no longer your fault, it's the guy who made the module's fault, right? Right, so that's sort of the standard cross-site scripting stuff. Okay, obviously another one of these, I guess, modern web app type stuff. And it's not web app specific, but obviously SQL injection, right? We all know what SQL injection is. And so, I mean, SQL injection bugs in Node look exactly the same as they do anywhere else, right? Again, no big surprises. The one thing that you'll see though is that, because Node.js is one of these sort of, you know, very typical Web 2.0 languages, is that you'll see this kind of aversion towards SQL. And so a lot of apps sort of try to go, they'll go to NoSQL, right? CouchDB or Mongo, or there's a long list of these, which, you know, they come with their own set of problems. They don't really have SQL injection, but there are other problems. But I'm not covering that here. So one thing you'll see is that there is relatively little SQL injected in Node.js. It's obviously not impossible. I found examples, and you can do SQL from Node. Also, Node doesn't offer SQL drivers by default. They're all modules. So if you want to use MySQL, for example, you do an npm, you know, install MySQL driver, and then you get the MySQL driver, and you can use that, right? And then obviously when you have that, you know, you say, oh, you make a network connection, you say, oh, network connection dot, you know, execute query, you say, query this, and you just append to a string user input. This is a, you know, classic SQL injection. Again, no surprises here. And I swear to God, there's a few more sides of these, but at some point I'm going to stop saying no surprises here, because there will be a few surprises. And so basically the next slide is sort of the, you know, so I started looking on GitHub for, you know, examples to show of what this looks like in real world, in the real world. And I didn't quite find a SQL injection, but I found a Yahoo query language injection, which isn't quite as powerful, but it's still pretty cool. Yahoo query language allows you to query stuff from Yahoo, and it's the language is very, very SQL-like, and there's a module for this in Node.js, and it's sort of the Yahoo query language selects from so and so and so, plus Weather City, and Weather City actually comes as input to the application. And so I spent a little bit of time looking at the Yahoo query language, and it does actually allow you to have multiple selects in one, so you can actually append stuff to it and query other data from this injection. Again, you know, SQL injections are no surprise at all. The way that we fix these things is to use, you know, parameterized queries or prepared statements, or depending on which world you come from, it'll be called one or the other, but they're pretty much the same thing. Obviously, the golden rule if you're going to do SQL is that you must always use prepared statements if the data comes from an untrusted source or is dynamic in any way. If you don't, you will have SQL injection, right? This is sort of the known rule. I mean, if you look at the last couple of years in sort of AppSec, is that people have sort of gotten, because SQL injection is pretty bad when people, for the most part, have done things right. Every so often you'll see people, you know, do this kind of stuff, but you know, usually things go okay. Right. So another common one of the cross-site request forgery. Well, yes, you have this too in Node.js. Again, no surprise there. Again, I'll assume that this audience knows what cross-site request forgery is. Again, this is not language dependent. You can see this in pretty much any web app, whether it's written in Node or ASP or Ruby on Rails or God knows what, right? Generally, when you see these things, it's a sign that you have a crappy design for your web app, right? Now, it's hard to show actual examples of cross-site forgery in code because cross-site forgery is sort of the thing that, it's the absence of code that makes a bug, right? The thing I didn't want to say about OWASP is that it doesn't offer native cross-site forgery protection. And I think that it should, because a framework like this is the perfect place to be like, hey, we'll just offer the token generation and marshalling all that stuff for you. You don't have to worry about it. You know, a bunch of frameworks do it. I wish Node.js does it too. However, if there are frameworks that do, so if you use eBay's Kraken.js, for example, they offer the, hey, we do session token generation, and you can opt into this stuff. So obviously, you know, again, this is pretty common advice. If you're using Node.js and you must roll your own to do cross-site forgery protection, it's sort of the this step of you need to generate a cryptographically secure token, and you need to put it in someone's session, and then you need to send it to them so that it's in their form, and then when they submit the form, compare to it. If they match, then great, get the request through. If they don't match, someone's trying to attack you, right? That's the basic idea. You shouldn't roll your own. It's actually harder than it sounds. Cryptographically secure is not as easy as I make it out to be, and I'll talk a little bit about that later on. Even though, and also the interesting about the cross forgery mitigation or protection is that this sort of came about in the, I'd say earlier, maybe mid-2000s, sort of right before we had this Web 2.0 model. And so the cross forgery protection is sort of the, well, we're going to assume that you have a static HTML and then you do a request to us. And so what we're going to do is when we generate the HTML for you, we'll just put the token in there and you submit it back. And that model doesn't fit that well in the Web 2.0 model where I'm not really sending you HTML anymore and you're not sending me all the stuff. All that's really happening is we're sending JSON back and forth. And so even though maybe cross-site request forgery, it's doing a token per request is one of these things where it gets really hairy. So again, not as easy as it sounds. Obviously, basically my advice is to use something like Kraken.js to protect against cross-site request forgery. And you know, the great thing about using libraries is that if things go wrong, it's not my fault, it's that guy's fault, right? Right, so okay, sort of the last piece of the sort of modern web app stuff is HTTP response splitting. I'm assuming everybody in the room knows what HTTP response splitting is? Perfect. Okay. Node.js is actually kind of clever about this. It doesn't really allow for response splitting. That is to say, it has APIs to set a header and a header value. You can't split the header value, but you can split the header name. So if you're in a rare situation where an attacker gets full or partial control of a header name, then that would allow for response splitting. It's rare. I'm sure it's happened before. I'm sure there's a case for it somewhere, but it doesn't happen often. This is what it would look like. This is a pretty complicated case, though, because I didn't really find an example for this, so I have to go make my own. But it's sort of the, I called it response outset header method, and this is my header name, and that's my header value, except my header name contains a colon in the next line, and then if you look at the actual you connect this to an application like that, and then sure enough you'll see there's a header injector there, right? So response splitting only works with the header name, not with the value. Basically that means Node.js, almost in all cases, you don't have to worry about response splitting. Node.js does it for you. In the extremely rare case where you have to set the header names to the header value, or where an attacker has control over the header name, you do have to worry about this stuff. Obviously, you have some options, right? I mean, you can do whitelist or blacklist. Like, am I just going to filter out next line, or if you send me a next line, am I just going to say failed request? Or so there's a few of these options that are relatively easy to do. Right. So far for the modern web app security bugs. So now we go into sort of classic web app security bugs, and this will be sort of reminiscent of 90s style Perl CGI script type bugs. And then I've seen some of this stuff in actual applications. So the first one's eval, right? If you've ever done any kind of client-side JavaScript, programming or reviewing, you know what eval is, right? Eval is basically, here's a string, and oh, by the way, this string is JavaScript, and go execute it, right? Well, server-side JavaScript, Node.js, also honors eval and has eval, and it works exactly the same way, and so it is exactly as bad as it sounds. If there is any piece of attack control data that gets passed on in that string, you now have server-side JavaScript code execution. This is really bad. One case where you would see this is because you have the same core, you have all of these client-side JavaScript libraries that you can be like, oh, you know what, I'll just import those things in my Node.js application. Except those libraries are never made to run on the server side. And so, for example, you have some of these legacy JavaScript APIs that sort of part JSON where they go like, I'll take their string and then I'll just eval it. If you port that to a Node.js application, you're completely owned, right? This is what it looks like. I kind of made a little example where you say, oh, give me a calculation, and I'll calculate it for you, and I give you the result. And the way I do is you give me the calculation request, I pass it on to eval, which will perfectly calculate it when you give it, because it's just eval's code, and enhance that result. But also, you get basically remote JavaScript code execution instead. How do you fix this? Well, just don't do it, right? Eval should be a banned API. It should never be okay on server side to call eval. I was talking to one of my buddies, and he was doing a security review, and he found one of these bugs that are just ridiculously easy. And he said, well, this is one of these bugs that I categorize in your stupid bugs, where you go to a dev and the dev goes, oh, you know what, I fix this immediately and no one will ever notice. And so I'd like to put forward that I think eval fails in the same, your stupid bugs. If somebody comes to you and says you have an eval bug, it's like priority, like drop everything else, fix this thing, and then sort of make sure no one ever knows that you put that bug there, right? So eval is one. Another thing that, so the Node.js JavaScript APIs, they're rich, right? It gives you a lot of access to the OS, gives you a lot of access to the file system, and so it gives you access to run arbitrary commands. And so there's one particular API called, if you require child process, and then you say, out of this child process object, call the exec method, that is basically the rough equivalent of the C system APIs, which basically means, you get a command line shell in your application, you say, oh, do this, pipe to that, and then pipe this application and semicolon, do this, and all of that stuff will just work, right? Except if you get any kind of user input in there, that's basically like command line injection, right? That's really bad. We know that's bad. We've known this for a very, very long time. And yet, I've seen this particular bug in Node applications that we've audited. And so the sort of equivalent of this is this sort of, there's another one called sort of exec, which is called spawn, which doesn't give you a shell, it allows you to execute one command, which is the better way to go. It forces off one process and just runs one command. But even then, if you just pass on arbitrary commands that come from an untrusted input, you might have like command line switch injection, right? And this is what it would look like. And this is a real world example. This is something I found on GitHub where it says, okay, I think you use Express something like it, where it says, oh, this is a post. We route the slash and code post requests that come in, and we say, oh, I upload an image. Okay, and say encode image name, and bam, right? If I give my image name and I put a couple of semicolons in there, it's game over, right? So basically, the advice for exec is sort of similar to eval, where it's like, just if it's a non-static string, don't do it, right? If it's a static string, I can see how you would do it, and it's probably okay. You're probably not going to have security bugs if it's a purely static string, but if it's any non-static string, don't call exec on it. Really, really, really bad idea. So What do you do then if you must call an application? Well, best way to do it is to, all of the sort of piping and so logic, well, you're going to have to do that in Node.js. I mean, you can still go call external applications. You're going to need to call spawn or exec file. And as I mentioned earlier, it's sort of but you're still passing untrusted content off to an application. So you have to be careful, and you have to ask, is the application built to handle this kind of input this untrusted input that I'm giving it? Maybe there's some kind of switch where, if you have something that says -- exec to you're adding something off to, then you get confusion again, right? So you have to make sure that the app is built to do that, and you have to make sure there's no switch injection. You have to make sure that there's the steps of things that you have to get done before you pass data off to an application, if you want to do it in some kind of secure way. Right? That was AppSec. Yeah, another classic, awesome bug is sort of the directory conversion. Yes, Node.js applications do have file APIs, and that means if you don't filter correctly, you will have directory traversals. It's basically, it's // and then if you don't filter for that stuff, then you'll be able to serve any file to any user, right? And that's exactly what happens. This is again another GitHub example I found where you say create server, and then the first thing you do is read file, and the first argument is sort of the HTTP root, and then append my request URL, and then that file's there, I'll just serve it to you. That works, and so I obviously I was like, it can't be this easy, and of course, sure enough, I tested, and yes, sure enough, I get my passing file back. The really, really sad part is that this is sort of this, there's this community of Node.js developers, and they all post all this code, and so on GitHub, a very large number of them have code exactly like this, where they say, create server, request, is this file system, I'll just hand it off to you. This is sort of Perl CGI scripts used to have these bugs, right? So it's like, the 90s call, they want their bugs back. The way to fix this is, don't do it, right? If you don't just serve files without doing any kind of validation on the file name, it's a really, really bad idea. If you must serve file names, data back to the user based on file names in the actual file system, at least do validation, right? Make sure it doesn't have directory reversals, right? Check for stuff like, dot and dot and things like that. Right, that's pretty much it for file bugs, right? Right, so that's sort of so now I have these sort of modern bugs, and then I've had these sort of classic bugs, and this is all stuff that's sort of pretty well known, and if you're going to be any kind of web app pen tester, this is all stuff you should probably know, and it's sort of this is what it looks like in Node.js, okay? So now there's sort of these, my last thing, sort of the things I stumble upon that don't really fit in those categories. Some of it is known secure territory, some of it is sort of little quirks that are Node.js specific. Let's start first about random numbers, right? Which is one of these things that we know about this stuff, but it's not web specific, right? So when I talk about cross-site request forgery, right, I said, well, you should generate cryptographically secure tokens. And then the next question you would ask is, well, how do you generate cryptographically secure tokens in Node.js, right? Well, you continue to ask, right? Node.js has these C++ APIs, and one of them exposes this crypto object. One of the things you can get out of crypto is random bytes. And you go to the API and you say, crypto.random bytes, what does that give me? And it says, well, it generates cryptographically strong pseudo-random data. It says cryptographically strong, I trust the documentation. It's all good, I'll start using that, right? Now, there's a similar API in the crypto object, which is pseudo-random bytes. What does that say? It starts off saying, generates non-cryptographically strong pseudo-random data. So this is non-cryptographically strong. So basically, if we just follow documentation, then we must have cryptographically strong. We use get bytes. Otherwise, we use the pseudo-random one, right? And this is an easy rule, and this would apply to cross-site request forwarding tokens, right? And so when I talk about cross-site request forwarding tokens, I said, okay, croc and JS, use that one. It'll do it right. Well, this is croc and JS code, and so what they do is when they generate tokens, they call the pseudo-random bytes. Which, of course, according to documentation, is wrong, right? Croc and JS should be using the one that doesn't use the random one that uses cryptographically strong, right? That's what it looks like at first sight. Fortunately, it's not that easy, right? So when I saw this, I'm like, oh, well, couldn't, when I saw this one, I was like, oh, these stupid devs, they know any better. Yes, it turns out they do know better. Because I started looking at the actual APIs, and you look at the C++ APIs. And they kind of, you come down to this, and because both APIs basically call the same function, but one of them basically says, I'm pseudo-random, the other one says, I'm real random, right? So and it's basically our very thin wrappers around OpenSL random code, pseudo-bytes and rand bytes, right? And then so you basically go to, okay, what does OpenSL do with this stuff? And then, okay, let's go look at the documentation for OpenSL. And for OpenSL, the documentation says, I don't know if you can read it, but it basically says, well, the rand bytes one guarantees cryptographically strong, and the pseudo-random one doesn't guarantee cryptographically strong, which matches almost one-to-one to the documentation of Node.js. So basically what they did is they wrapped the OpenSL API, they just copy-pasted the documentation, and they said, okay, there you go, now it's OpenSL's problem. So if I want to do cryptographically strong tokens, I'll go use Crocker, and Crocker says, well, Node.js can do API. Node.js says, well, actually, OpenSL gives me these APIs. And actually, if you look into the bowels of OpenSL, OpenSL doesn't just, they have these crypto providers, and so they say it's this crypto provider's fault. And so you keep shifting all this blame, right? The real problem, of course, is that getting cryptographically strong numbers is kind of a pain in the ass. The way it works is that you have to generate a feed, and you sort of expand it, you can't, it doesn't fit well in the Node.js model because Node.js, everything is asynchronous, right? And sort of the way you get really strong random bytes is sort of let's sit here and wait until we get entropy, right? And then that model doesn't really work so well. So what they should do is sit there and wait, and of course they don't, and they fail. And so if I'm trying to make a Node.js application that is trying to be practical, I'm not going to use the cryptographically strong API because it doesn't work in my model. I'm going to go ahead and use the pseudo-random one, keep my fingers crossed, and hope that it's cryptographically strong enough that it's not predictable. So how do we fix this? Well, I don't really know. I don't have a good answer to this. I guess you could pre-allocate a large pile of random data, but then when that runs out, well, then maybe you should have a daemon that just sits there and collects entropy. Well, what if you get more requests and you collect entropy? Or maybe the APIs should expose when you do the when you get the pseudo-random bytes, but when you get non-crypto bytes back, non-cryptographically strong bytes back. Well, maybe Node should expose that to developers. Maybe there's. This is sort of a bigger argument, and sort of this is really a talk in itself. And in fact, it is a talk in itself. My friend Dan Kaminsky did a talk about this at DEF CON last year. And he has a couple of solutions, including sort of a userland, cryptographically strong-ish pseudo-random number generator that he created. And it's called liburandy. And it's also supposed to work with Node.js, by the way. So if you want better answers to this problem, go look at Dan's talk. Right, so let's move on to the next bit. Node.js has this API called console.log, where basically, anytime you run a Node.js application, you can just sort of get it to spit out stuff to the console, which is really nice because it doesn't require any extra methods. It's just sort of baked in and allows you to spit out debug messages, right? And if you look on GitHub, which I did, and you see all these apps, and they're constantly using console.log to get all sorts of debug information out. Oftentimes, where the console.log contains information that comes from untrusted sources, right? So if you just sort of do like raw, allow any kind of raw data to come through, that's not great. It's not terrible. It's not bad per se. It's not a security bug on its own. But it's one of these things where it sort of spills over, right? It's like, well, if I go inject stuff, if I go to a log file at some point, an administrator is going to start looking at this stuff, and this is where you get sort of problem where generally the tools administrators use to look at log files, they're not really built to handle untrusted data, right? So if I get to inject arbitrary terminal escape codes into your log data, and the admin has that open in his terminal, depending on how good or how bad your terminal is, that may be really bad, and maybe your admin just got on, right? That's really bad. The other one is, for example, that by default it just sort of prints out these non-printable characters. So you get all these things where you could be like, oh, let's erase this line, or let's add a new one, or let's inject this stuff. So if one of the things you want to do is you want to fool an admin into seeing something that isn't there, or not seeing something that is there, you can inject all these unprintable characters and sort of get things put on the screen or removed from the screen that aren't really there. And so, console log raw injection isn't that bad, but you get all these weird side effects, right? And so, I mean, a simple example of this, right? You get console log, and this thing goes through the network, and then you get all these sort of weird side effects. Yeah, how do you fix that? It's pretty easy. You basically do a wraparound, and you say every character that isn't within the known ASCII range, we're just going to hex escape that thing, right? And that sort of takes away the problem, right? I really believe that Node.js should have had a second API, like console.log printable or something. But since it doesn't, if you're going to use console.log and you know you're going to get untrusted data back in there, make a wrapper and basically go like, okay, anything that's not an ASCII range, we're just going to hex escape it. Okay, so this is sort of my last bit. This is sort of a Node.js specific sort of work that I sort of stumbled upon that I think was pretty cute. So Node.js is sort of meant to be this super fast, super performant, completely asynchronous, single-threaded framework, right? And so it uses the V8 engine underneath, which is pretty good. But the problem with JavaScript, of course, is that you're using JavaScript data structures, so strings and arrays. And the problem with those data structures is that they obviously come with managed language overhead, because that's what you want. You want it to be that way. But it kind of hits you on curve. So Node.js guys basically said, okay, well, we'll still have those, but we will go create our own data structure called the buffer class. What a buffer class really is that it's this really, really thin layer implemented in C++ that basically gives you this, it basically wraps you in delete. You get this, as a developer, you get this raw block of data that has just been located, and you go like, here you go. And when I say raw, I mean raw. Like nothing's been initialized. You get malloc from JavaScript, basically. And the kind of scary part is that it's used everywhere. Like any Node application you will see, they will use the buffer class. And there's sort of three ways to use this buffer class, right? The first way is sort of give it a length. It's really just malloc. It's like, give me 100 bytes, and it says here's 100 bytes. Or the more sane methods, which is sort of the, okay, I have this JavaScript array, please do a malloc and just put the bytes there and give me the raw bytes, right? And the same thing with instead of an array, it's a string, right? If you use the array or a string, things probably are good. Of course, the length one is the one that's really worrisome, where basically you, from a JavaScript developer, you say, go to Node.js and say, hey, just give me 100 bytes of raw memory. What that means is it's all initialized, right? There's not a single byte initialized, because that would be a perfect. Now, if you're a C and C++ developer, that's cool. You're used to that stuff. If you're a PHP developer or a JavaScript developer, this isn't stuff you're used to. Nobody ever told you to initialize data because you assume that it's initialized. And the reason they're not doing it is for perf reasons, but at the same time, your developers aren't used to getting that kind of raw memory. And so this was really scary to me because the potential for Heartbleed-like bugs is enormous. I think they're just sitting out there, waiting out there. I know the next time I'm going to go kind of test a Node.js application, this is the stuff I'm going to look for, right? Because if you run this thing and you have a self.fit, and I can fish out your keys by just requesting data, that's really bad, right? And so, I was reading over the buffer documentation and reading this, I'm like, really? They're really giving me back inside data? Of course, couldn't believe it, so I open up Node and I say, give me a buffer 55, and sure enough, it gives me random, whatever was there in the heap, do it again, and you get a completely different set of whatever's there in the heap. And every time you do it, and you start seeing these little structures in there, you're like, okay, this must be some piece of initialized data. That's one thing about the buffer part that I think is really scary. And while I was doing this, I was sort of looking at sort of the other angle. Okay, I get initialized data, and that's really bad. You get this Heartbleed-like thing. But if I get raw data from JavaScript, do I also get to just read and write anywhere I want? So how do you rewrite from these buffers? Well, the Node.js basically sort of gives you two ways of doing it, right? You have the bracket operator, and then there's these read and write APIs, right? So the good thing about the bracket operator is that it does bound validation. So if you go out of bound the bracket operator, it goes screw you and it throws an exception, right? Which is exactly what you want. Now, the read and write APIs aren't quite as straightforward. The read and write APIs basically have, if you look at documentation, it's sort of, okay, well, if you do write, then write this value, and write this value, this opposite. Oh, and there's this third optional argument which says no assert. Okay, what does no assert mean? Well, no assert means that if I set it to 1, it won't throw an exception if you go out of bounds. But it then goes on to say, if you go out of bounds, it will be silently dropped, right? That's what it says to the write API. Then you go to read API and it doesn't say that. It still says, oh, there's this optional no assert, but if you turn that thing off, or if you turn no assert on, then it won't throw an exception. It doesn't explicitly mention that it won't discard the out of bound index, right? So I think that's strange that it doesn't explicitly say that. And I started playing with this. And it turns out that reality is stranger than the documentation. In reality, all the read and write APIs for integers will silently ignore out of bound. Now, and then you start looking at the read and write APIs for floats and doubles. When we write float doubles to or from a buffer class, and they do not silently drop. It just goes through. So if I basically go and say, hey, write this float to this index way past the buffer, it'll just write it. It doesn't really match with documentation. So I think that's an implementation oversight. I tested it on 0.10.31, which is now a few months old, but I suspect the latest version has it too. I'm hoping this will get fixed. I really think it's an implementation oversight because there's no reason why you have this kind of discrepancy. It doesn't make much sense. Again, if you want to start testing this, it's sort of you create a buffer and then you say, oh, buffer read float outside, and then you get a value back that's clearly outside of your range. Then when you say, oh, write this value to this index that's way too large, it crashes and you crash on a memory corruption, right? This is a buffer overflow. Right, so if you're going to use a buffer class, and if you're a Node.js developer, watch out with allocations. Sending undersized memory over network can have disaster consequences. We saw it last year with Heartbleed. It can be really, really, really bad. So if you're a Node.js developer and perf is an absolute must on everything, the first thing you should do when you create a buffer is you should mem set it, if at all possible. And if not, just be really, really careful that you're not sending out undersized data. Right, secondly, for the buffer, I think the out-of-bound read and writes, I think that's an implementation oversight. It'll probably get fixed, but it's weird that it doesn't match with documentation at all. Right, okay, so that's pretty much what I sort of, what I came across in my Node.js research, and I hope you enjoyed it. I hope it was useful. I think, so Node.js, is pretty similar to other runtime sort of applications. It battles with the same problems that we've known for quite a while, and that other frameworks languages have too. And sometimes it sort of feels like, oh, I saw this in a Perl script in 1998. So some of them are pretty cute, sort of nostalgic. And then you get sort of these new, sort of cute new ones that I haven't seen really before in languages like that, like the buffer class. I think that's interesting. And so I think there's Node.js stuff has some interesting areas for security research. I think there's a few cool things we can still do there. Yeah, that's pretty much my talk. Yeah, go ahead.
I don't think you mentioned dropping privileges.
I did not.
You should do that.
I will make a note of it. Thank you, sir.
Because you need to start your node server sudo.
Yeah, if you're going to run port 80, yes, absolutely. That is a really good point, sir. I will make a note of that.
Put user ID and group ID.
Yes, absolutely. I will make a note of that. Thank you.
Have you tried notifying the project owners?
So, it's on my to-do list. Well, I mean, for Node.js, right? for the GitHub ones, I haven't even tracked these things. I just basically grepped for stuff that I wanted to include. And I was like, oh, this looks wrong. I'll copy paste.
Well, I guess the more interesting question is the owners of Node.js project, which they can improve from.
Yeah, I still, so in particular the buffer one, right, the out of bounds stuff. Yeah, I gotta go talk. I know who the developers, because I figured out who it was. I haven't mailed them yet, but it'll basically, once I get out of this room, it's what I was up to 6 in the morning making these slides because, there were a few other things I had to do. So I haven't gotten around yet to emailing yet, but I will. I don't think I don't think anybody's in danger for the buffer overflow stuff because the way to do it is a little bit convoluted. In theory, yes, there's a security bug there. I suspect no one is exposing this right now. But I mean, it clearly is some kind of violation because at the very least, the documentation is completely inconsistent. And I think something should be done there. And I will be informing the developers that just haven't gotten to it yet. Right. Cool. Any other questions? Oh, yeah.
Did you look at all the security of NPM and how easy or?
I have not. It's one of the things I want to do. I hear you. I think, and I know there's a project out there that does these periodic security reviews of stuff that goes through NPM. I haven't looked at most of that stuff yet, but I know there's a project that does that. Any other questions? Awesome, great. Thanks for listening. I hope you enjoyed it.
Yes.